Question 5. A rotating sprinkler is at a fixed point S. It waters all points inside and on the circle of radius 20 centimeters. Point S is 14 meters from the edge of a path, which runs in a north-south direction. The edge of the path intersects the circle at points A and B. This information is shown in the following diagram. Show that AB equals 28.57, correct to 4 significant figures. Let's label this as C. So AB equals 2 times AC equals 2 times square root 20 squared minus 14 squared equals, we got 28.5657, 28.57 as 4 sig figures. The sprinkler rotates at a constant rate of 1 revolution every 16 seconds. Show that the sprinkler rotates through an angle of pi over 8 radians in 1 second. The angle for one rotation is 2 pi. Let's do the ratio. 2 pi over 16 equals x over 1. Cross multiply. X equals pi over 8. Let t seconds be the time that AB is watered in each revolution. Find the value of t. Let's label this angle is theta. So cosine theta equals 14 over 20. And theta equals inverse cosine of 14 over 20. Let's set up the ratio. Pi over 8 over 1 equals 2 theta over t. Let's go to equation solver. First of all, we figured out theta times 2 will be central angle to theta. 2 theta pull down over A as a variable. Control menu, enter, enter, enter. Answer is 4.05. Consider one clockwise revolution of the sprinkler. At t equals 0, the water crosses the edge of path at A. At time t seconds, the water crosses the edge of the path at a movable point D, which is a distance d meters south of point A. Let alpha equals angle ASD, beta equals angle SAB, where alpha, beta are measured in radians. The information is shown in the following diagram. Write down an expression for alpha in terms of t. Since 1 second, the central angle will be covered pi over 8. So alpha equals pi over 8 times t. It's known that beta equals 0.7754 radians, correct to 4 significant figures. By using sine rule in triangle ASD, show that the distance d at time t can be modeled by d of t equals this. We will use sine law to figure out this d. So d over sine alpha equals 20 over, this angle will be pi minus alpha plus beta, sine pi minus alpha minus beta, cross multiply, d equals, denominator is sine, pi minus alpha is pi over 8 times t, minus beta is 0.7754. Numerator 20 times sine, pi over 8 times t for alpha. Simplify. We got 20 times sine pi over 8t over sine 2.37 minus pi over 8t. A turtle walks south along the edge of the path. At time t seconds, the turtle's distance j meters south of a can be modeled by this function. At t equals 0, state how far south the turtle is from a. G of 0 equals 18. Let w represent the distance between turtle and point D at time t seconds. Use the expressions for j of t and d of t to write down an expression for w in terms of t. W present the distance. We will use absolute value. J of t minus d of t, which is 0.05 t squared plus 1.1 t plus 18 minus 20 sine pi over 8t over sine 2.37 minus pi over 8t. Absolute value. J2, hence find when and where on the path the water first reaches the turtle. When W equals 0, the water will reach the turtle. Let's sketch the graph. First of all, check angle is in radian. Then type in J function for f1 of x. Go back to this tab. We don't need to graph this function. Then f2 of x equals x. Enter. Go back to this tab. We don't need to graph this function. Tab again. Let's go to f3 of x. Click this template to get this absolute value. Then variable f1 of x minus variable f2 of x. Then enter. Go to menu. Go to 6, 0. X-intercept is 3.35. By graphing, t equals 3.35. Then the distance, they ask you when and where. So we need to figure out g of 3.35 equals variable. We know we put f1 is the g function. Type in 3.35. Enter. Answer is 22.2. So at 22.2 meters sounds of A, the water reaches the turtle.